Okay, we're still in 1.6. I want to talk to you about exponents for a minute. I know you learned about exponents probably a long time ago, so it's time for a little bit of a refresher. If you have an exponent that's a fraction, then the top is the power and the bottom is the root. Write this in your notes or at the top of your paper when you're working these problems so that you can keep track of what you're doing. So if you have something like this, x to the 3/4, it means x is raised to the third power and the fourth root. Thing is, which comes first? Do you raise the x to the power first and then take the fourth root, or do you take the fourth root first and then raise the x to the power? Well, it doesn't matter, because if you have something raised to a power and then raised to another power, then you're just multiplying the powers, right? And something I neglected to write down here, that this also equals b times a, because a times b is the same as b times a. Multiplication is commutative. Therefore, it doesn't matter which thing you do first, the power or the root. So the thing to remember is when you're working with numbers, it's usually easier to make the number smaller before you make it bigger. You'll see what I'm talking about in the next problem. So let's say that we have x to the fractional exponent equals a. So this says that if you take whatever value of x is and you cube it and then take the square root of it, the answer is 8. So that's what we have here. And you could do it either this way or this way, but like I said, it's easier to make a number smaller before you make it bigger, right? That's the blue note right here. So if I have this problem right here, how do you get rid of a cube? You take a cube root. So I'm going to take this side and take the cube root of it. So the cube root of something cubed, this guy right here, is just the stuff before it got cubed, right? And you take the cube root of this side and you get 2. So the cube root of this is the square root of x, the stuff in the parentheses, and the cube root of 8 is 2, and I get this right here. All I did was take the cube root of both sides. Now, how do I get the x out from under the square root? We've been there and done that in the last video. We squared both sides, right? So you square a square root, you get the x. You square the 2, you get a 4. Now, remember that we squared both sides, so we have to check our answer. Plugging the 4 into the original problem up here, 4 to the 3/2 power means I'm going to take the square root of the 4 because it's a number. It makes it easier to go smaller before you go bigger. I don't want to cube a 4 and then find the square root, right? I'd rather find the square root of the 4 first. So the square root of 4 and then cubed, well, the square root of 4 is 2. 2 cubed is 8. 8 is what it's supposed to equal. And so that is a good answer. Wait a second. What did we just do? There was a whole lot of steps in there, right? So let's see what we did on the next page. It's an easier way to do these. So we had x to the 3/2 equals 8. First we took the cube root and then we squared it. But remember, the top is the power, the bottom's the root, right? So what we did to this thing right here was we raised it to a fractional exponent. Top was the power, the bottom's the root. We squared it and took a cube root, and we did that to both sides. Now remember, when you have a power to a power, you multiply the powers. So what happens to this power here? We have x to the 3/2 to the 2/3. The 3 on the top, the 3 on the bottom, they canceled. The 2 on top and the 2 on the bottom, they canceled. We ended up with just x to the 1. And now we did raise the 8 to the 2/3 power. We want to cube root the 8 to get a 2, square that 2, and we get our answer is 4. So notice how we raised this thing to the reciprocal power, and that's the key. When you raise it to a reciprocal power and you do it to both sides, you're still keeping the equality, because if these things equaled each other in the first place, then those things to any power will still equal each other. So we raise both sides to the reciprocal power, and that gives us a plain old x, and we have solved. All we have to do is calculate the value. So now try this. We have blob to the power. Well, we're just going to flip that power over and raise both sides to the 3/2. So we've got blob to the 2/3 to the 3/2 is just blob to the 1. 4 to the 3/2 is the square root, and then cube it. So the square root of 4 is 2, cube the 2. We get the stuff in the parentheses equals 8. Add the 3 to both sides. Boom, you're done. Let's try one more. Okay, this looks a little bit more challenging, right? It's not. Just isolate the thing that's raised to the power by adding 1 to both sides. Then you raise both sides to the reciprocal power. And by the way, 1 to any power is just 1. Don't ever write the square root of 1 on your test, okay? So on the left-hand side, we raise it to the reciprocal power, we get the stuff in the parentheses. The right-hand side simplified to be 1. So how do you solve this equation? Well, the only way you can do this with two different powers of x here is to get it equal to 0. So I'm going to subtract the 1 from both sides. That gives me this. We have done this before. This is simple. You factor or you complete the square or something like that. So this factors, I'm going to factor it out. The factors of 2 that add to be 3 would be a 1 and a 2, and both of them are subtraction. So we factor it out, we set the factors equal to 0, and we solve for x. But wait, look at this power. We took the cube root, but we squared. If you square both sides, you have to check your answers. So I plugged in the 1, calculated it all out, and it worked. I plug in the 2, calculate it all out, it works. Boom, both answers are good. So this is just a very small portion of 1.6. You only have a few problems to do. Try it. It's the same stuff you did when you had radicals before. It's just that the radicals are written as exponents now.